Welcome to AMAC KSSM channel. This is KSSM at Max Form 5 exercise discussion. I'm Madam Wong here. Self-exercise 8.5. Number 1. A particle moves along a straight line. Its velocity v meter per second, t seconds after passing through a fixed point O is given by v equals to at minus t squared. Find number 1a. The initial acceleration in meter per second square of the particle. So we are given the function v and we need to find the acceleration. So acceleration is the rate of change of velocity. Therefore, we need to do differentiation to get the acceleration. So differentiate 8t minus t squared, we get 8 minus 2t. And we need to get initial acceleration. So initial acceleration means I want the acceleration when the t equals to 0. So when t equals to 0, this will be 0. So A is just 8 meter per second square. B. The acceleration in meter per second square when the particle stops instantaneously for the second time. So the clue is when the particles stop instantaneously. So from here, we know the v equals to 0 for the second time. So means that the particle not only stopped once, it stopped for more than one time. Okay, and we want the second time. So start from v equals to 0, we'll get 8t minus t squared equals to 0. So by factorization, we get t equals to 0 or t equals to 8. So this is the first time where the particle stopped, alright, which is start with s equals to 0. Then it stopped when t equals to 0. And it happens again. So this is the second time. So this is the time that we want to look for the acceleration. So when t equals to 8, a will be 8 minus 2 times of 8, which is negative 8 meter per second square. C. The time in seconds when the velocity is uniform. When the velocity is uniform, then we have no acceleration. Therefore, a equals to 0. So when a equals to 0, 0 equals to 8 minus 2t, there we get t equals to 4 seconds. Number 2. A particle moves along a straight line so that t seconds after passing through point O, its velocity v meter per second is given by v equals to t squared minus 2t minus 8. Find a. The time in seconds when the acceleration of the particle is 0. So we need to find the acceleration. Therefore, we need to use the function of velocity and get the rate of change of velocity to get the function of acceleration. So a equals to the 2t minus 2, where we differentiate the v. So when the acceleration is 0, alright, so a equals to 0, 2t minus 2 equals to 0, and we get t equals to 1. B. The range of values of t in seconds when the particle experience deceleration. So deceleration happens when v and a are opposite sign. Means that when we are moving forward, but the acceleration is actually backward. So we are decelerating. Or when we are moving leftward, but the acceleration happen toward the right. So we are actually experience deceleration. So we will start with the first case when the v greater than 0 and a less than 0. V greater than 0, we have t squared minus 2t minus 8 greater than 0, where t minus 4 times t plus 2 greater than 0. So from the function, we know t is supposed to be less than 2 and greater than 4. But end up, we only choose t greater than 4 because t cannot be less than 2. We don't have negative t. Alright? And second condition, a must be less than 0. So the 2t minus 2 less than 0, we get t less than 1. Therefore, combining these two solutions, we get a t, the range of t where t less than 1 and t greater than 4. So we see there's no common t values that is less than 1 and at the same time it is greater than 4. Therefore, there's no solution. Now, second condition, second case, alright? So when v less than 0, when we are moving leftward, but the acceleration is to the right, alright? So we are decelerating also. So when v less than 0, t minus 4 times t plus 2 less than 0. There, from the graph, we want less than 0, therefore is here, alright? Although this is from negative 2 to 4, but we still start from 0 because t can only be positive or equals to 0, right? So t is from 0 to 4. Then when a greater than 0, the 2t minus 2 greater than 0, t greater than 1. So we have two solutions here and we put it in the number line. So first condition, t is from 0 to 4. So 0 to 4. Second condition, t must be greater than 1. So t must be greater than 1. So from this solution, we see intersection of the two conditions. Therefore, our t is from 1 to 4. The particle experienced deceleration. Thank you.